Hello everyone. My name is Malcolm McPherson, and this is my final presentation for the Raspberry Pi RAID web server project. Over the course of this project, I set up a RAID 1 mirrored stage storage array using two USB drives connected to a Raspberry Pi. And then I hosted a fully functional Apache and PHP web server directly from the Pi. This project gave me hands-on understanding of Linux storage management, server configuration, and the deeper architecture behind the Pi's hardware interfaces. I'll be walking you through the reasoning behind the project, how it connects to Raspberry Pi architecture, the procedures I followed, the results I achieved, and a few troubleshooting hurdles, and what I learned in the process. Project rationale. I chose this project because I wanted to work on something that was both practical and directly applicable to real world infrastructure, including my major, which is cybersecurity. Um, a RAID-backed web server is a kind of setup that mirrors what you'd see in enterprise environments with redundancy, persistent storage, and live services. Using a Raspberry Pi to build it made it even more interesting because it showed how even minimal hardware can be used to replicate systems found in production environments. It also gave me a chance to explore topics like Linux system administration, RAID storage, boot configuration, and web server architecture in a controlled way. Architecture connections. This project touches several core parts of Raspberry Pi architecture. The first being a storage component. I configured two USB flash drives into a RAID 1 array using MD80M, which allowed the Pi to treat them as a single mirrored device. This protects against data loss if one drive were to fail. Then there's the file system. I formatted the new RAID array with ext4 and updated /etc/fstab using the UUID so that the RAID device would mount automatically after every reboot. For boot configuration, I edited /etc/md80m/md80m dot conf file and ran update dash ini tramfs space dash u to make sure that the system could reassemble the RAID during startup. On the networking side, I installed Apache and PHP and configured the server so that it could be accessed through the Pi's local IP address on like any network on finally this whole setup relies on the Pi's USB controllers, which are used to interface with the external drives and handle storage I/O. A great example of how peripheral access ties into system performance and service delivery. Procedure. To get everything working, I started by partitioning both USB drives using fdisk, removing any existing partitions and setting the new ones to the Linux RAID type. I then used MD80M space dash dash create to build the RAID 1 array from those two partitions. Once they were created, I formatted the RAID device /dev/md0 with ext4 file system and mounted it at /mnt/RAID0 to ensure it would mount every time the Pi booted. I found the UUID using lsblk space dash f and added it to /etc/fstab and created the mount directory. After that, I moved on to installing the web server software. I installed Apache and PHP using apt, created a PHP info page, and confirmed it was loading correctly in the browser. To prepare for more dynamic hosting, I would also install and secure MariaDB using MySQL underscore secure underscore installation, which laid the foundation for potentially hosting WordPress or other dynamic sites on the RAID protective drive. This is the Apache default page, and on the right here is the download for MariaDB. The results. The system works exactly as planned. The Apache welcome page loaded from the Raspberry Pi's IP address, showing that the service was active. The PHP info page rendered correctly, confirming that the server-side scripting was running. More important, the df space dash h output confirmed that the RAID array was mounted as slash dev slash md127 was active and mounted at slash mnt slash RAID 0 and had persistent storage. I even tested this by creating files inside the mount directory and rebooting the Pi. After the reboot, the files were still there, and the RAID reassembled properly and automatically thanks to the UUID and the MDADM boot configuration. These results prove that the Pi was running a redundant and functional web server off mirrored storage. And up here, but right next to results was the test file that I created. Troubleshooting. Not everything went smoothly the first time. One of the biggest issues I ran into was with screenshots. I was using the scrot command and the built-in Raspberry Pi screenshot accessory. Um, and I was taking screenshots along the way, but I didn't end up like checking the screenshots after I took them, and all of the images came out completely black. This happened because I think I was running the Pi headless over VNC without a virtual display. Um, I solved this by using the print screen command, which worked opposed to the scrot command or the screenshot accessory. Another problem that I ran into was a bad superblock error when trying to mount slash dev slash md0. This happened because I hadn't formatted the array yet, and after running mkfs.ext4 on the RAID device, the error went away. And finally, the RAID didn't mount like properly after reboot initially. So I had to fix it by making sure the UUID was correct in slash etc slash fstab and by saving the RAID config to slash etc slash mdadm slash mdadm dot conf, followed by running update dash ini tramfs. After that, the system was able to boot cleanly with the array mounting automatically. Lessons learned. This project taught me a lot how the real Linux-based infrastructure works. I learned how to configure and monitor a RAID 1 array using just the command line and how to fix mount and boot issues by understanding how FSTAB, MDADM, and INI interact. I also got a better grasp on how the Raspberry Pi's USB architecture and network stack can be leveraged for hosting lightweight services. And if I were to do this again, I'd automate much of the process using a shell script, and I'd also test what happens if I unplug one of the USB drives during operation, just to fully simulate a RAID recovery scenario. Um, Something I'd also do is check my screenshots after I take them, um, like immediately to make sure that they actually went through and were saved, because that did cause me to lose a lot of information and steps along the way, like documenting the steps along the way that I could have put in this presentation and wasn't able to. Thank you. That wraps up my Raspberry Pi RAID web server project.